Hey folks, welcome back. In this video we're going to go over question 2 from the 2023 SQA Advanced Higher Physics exam paper. So let's get started. Question 2 says a student is investigating rotational motion using the circular plate in a microwave oven. This is shown in figure 2a, so there's the circular plate there. Part A says the microwave oven is switched on and the plate rotates with an angular velocity of 6.2 revolutions per minute. Show that the angular velocity of the plate is 0.65 radians per second, and there's 2 marks available for this. Well, to answer this, we first want to find the angular displacement theta and then the angular velocity omega. So to find theta, we can say that 6.2 revolutions is equal to 6.2 times 2 pi, because remember, one full revolution, one full circle, is the same as 2 pi radians. So 6.2 times 2 pi gives us 12.4 pi radians. And then to find omega, the angular velocity, remember we can use this equation omega equals d theta by dt, but we can generalize this to just omega equals theta over t instead. So we're trying to find omega here. We know the angular displacement theta is 12.4 pi radians, and lastly the time t is 60 seconds since we're talking about per minute here. So 1 minute is 60 seconds. So writing down this simplified equation omega equals theta over t, substituting in the numbers, we have 12.4 pi divided by 60, and putting that into your calculator should give you an answer of 0.65 radians per second, as expected. Part B says the microwave oven is switched off. The student places a P on the plate 83mm from the axis of rotation as shown in figure 2b. So there's the P placed at 83mm from the centre of the plate, which is the axis of rotation. It then says the microwave oven is now switched on and the plate again rotates with an angular velocity of 0.65 radians per second. B part 1 says the P has a mass of 0.36 grams and follows a circular path. Calculate the centripetal force acting on the P. So writing down what we know from the question, we're trying to find the centripetal force F. We know the mass m is 0.36 grams, which we need to convert into kilograms, so that's the same as 0.36 times 10 to the minus 3 kilograms. We know the distance r from the axis of rotation is 83mm, and again we need to do a conversion here, so we need to change millimeters into meters. So writing that in meters, we have 83 times 10 to the minus 3 meters. And lastly, angular velocity omega is 0.65 radians per second. So writing down our equation for centripetal force in terms of angular velocity omega, we have F equals mr omega squared. Substituting in the numbers gives 0.36 times 10 to the minus 3 times 83 times 10 to the minus 3 times 0.65 squared. And if you put that into your calculator, you should get an answer of 1.3 times 10 to the minus 5 newtons. B part 2 then says state the direction of the centripetal force, and there's 1 mark available for this. Well, remember centripetal acceleration and centripetal force will always act towards the centre of the circular path. And I've underlined the words centre and circular path as it's important you mention those words in your answer. Lastly, part C says the microwave oven is again switched off. The student places a second identical P on the plate, 120mm from the axis of rotation as shown in figure 2c. So there's our first P at a distance of 83mm from the axis of rotation, and then the second P placed a distance of 120mm away from the axis of rotation. And it says the microwave oven is switched on. It then says explain why the second P is less likely to follow a circular path as the plate reaches an angular velocity of 0.65 radians per second. Well, we could say from the equation that we used earlier for centripetal force, F equals mr omega squared, the required centripetal force F is greater for the second P since its distance from the axis of rotation r is greater. And remember, we're told that the second P is identical to the first one, so the mass will be the same for both. So if r is greater for the second P, then F will be greater for the second P, and both are going to reach the same angular velocity omega of 0.65 radians per second. And therefore we can say the friction between the second P and the plate is insufficient to provide the required centripetal force. And therefore it's less likely to follow a circular path compared to the first P. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.